form look like?
X plus B.
Okay.
I didn't know that.
Can we write this down?
What does the M stand for?
Slow.
Okay. Slope, change in Y, change in X, rise, overrun. Your B values are what?
Intercept.
It's your intercept. Which intercept?
Y.
It's your y-intercept, hence why we call it, we have slope-intercept form. One of the nice, easy things to do here is with slope-intercept form, the reason we use it, because there's a button on your calculator that says y equals. That was one of the reasons why it was so nice to be able to put things into slope-intercept form. Now, more often than not, you probably won't have a lot of stuff in slope-intercept form, but you will have things that are what are called standard form. It's a form you probably didn't work a whole lot with in Algebra 1. You might have worked out of it. AX, BY, and C. When we worked with this one, a lot of times teachers in Algebra 1, they would get you guys to go into slope-intercept form because it was more of an easier way to graph stuff. I know that there's a lot of different rules and regulations with what they call standard form. A and B both can't be 0. And there's a lot of little things like that. It really isn't that big of a deal at this point in time with those rules and regulations for standard form. It's just another way to write out equations. I think I showed you guys. What's wrong, Gabriel?
What's that under rise?
Run.
Oh, and then call you out on this.
Alrighty.
Alright.
The look on his face was like, oh, what happened?
So I didn't know what I like.
That's okay.
I was lost.
Yeah. Anyway, so what happens a lot of times with this standard form, you get problems like this. 3x plus 2y is 6. If you're going to graph that, you guys were always taught to move things around and get slope-intercept form.
Can you write this down in examples?
You can do whatever you like. Might not be a bad idea. What I would do is show you guys how you can graph things when it's written in standard form, because it's easy. When you have a y-intercept, what's your value of x? 0. Okay? Because if you hit the y-axis, the value for x is 0. What's your y-intercept?
3. No.
Oh,
3.
3.
When you have the x-intercept, what's your value for y? 0.
Oh, shoot.
If you listen, your x-intercept is, oh, you're forgetting to listen, I know. Jeez, wow. That means your y value is 0, so, what's your x-intercept?
Oh, gosh, bless it.
What?
We're supposed to do.
How many points determine a line?
2.
Really?
You're done. That's how you.
So,
That's
A
right.
is always, that's my constant term.
No, what's saying here is that your y-intercept is when x is 0. Just cross out. You're putting 0. All I'm doing here is, all I'm doing by putting 0 is I'm just covering it and solving it. By covering it, because what's 3 times 0? This goes away.
I kind
all it
of
is.
lost you. The way I'm reading it is you reverse the points. Like
It's dumb luck. It's dumb luck. It's dumb luck that happens. Okay. Doesn't always that clear. Another one. If you have negative 6x plus 2y is 18. Do the same basic idea. If I want to graph this out, I plot my intercepts. Cover and solve. Cover up your x, solve for your y-intercept. Well, what's your y-intercept? 9. Cover up your x, solve, or cover up your y, solve your x. you're doing is you're solving for your intercepts. This is called quick graphing. We use it a lot with this stuff, a lot. It is much easier, it's much quicker, it's much simpler to work with when we start doing multiple equations at the same time on one grid. Okay? You don't always have to solve for y. It's kind of a waste, especially if you give it to you standard form. So it's not just flip-flopping your values. You see what I'm saying, Zach? It's just done luck.
Yeah, I had trouble understanding the cover part, but then I realized you basically just threw it.
Yeah, just put 0 in. And that by covered it means it's gone. That's all.
And the 2y equals 18 and then the 6x.
Yeah, that's why I put a different one up there, because you were thinking of it. So what this allows us to be able to do is to start to graph systems. And when we graph systems, it's nothing more than putting more than one on the same. But before we graph systems, we have to remember, what do those symbols mean within graphing? We have to shade. But we also have to remember, are they solid or dotted lines when you're connecting your dots? Dotted. Why are they dotted? Because it's not equal. Correct. It's the same idea about when you had single value, when you had y was less than 3. If you had y was less than 3 on a number line, you put 3, here's 0, and it's going that way. It was an open circle. Nope. Because less than, it just means it doesn't include 3. Okay.
I was really mad.
Well, you'll get better.
It was kind of useful too, so.
Okay. So if you're going to graph two of them on the same, notice I'm not giving graph paper out because we don't need it. We're just getting a rough idea of what this looks like. These guys are in slope-intercept form, so we use them. First equation is y is less than negative 3x plus 3. What's your y-intercept? 3. And what's your slope? My slope was? So when my slope is negative 3, what direction do I go first? Down 3, and then where? Over 1, because it's 3 over 1. Remember? Down 3 over 1. Down 3 over 1. When I connect those dots, will it be a solid or a dotted line? Dotted. So just go. When you're graphing two variables on the XY grid, you have, what happens is you create two half planes. I don't know if you remember this from geometry when we talk about a plane, flat surface that expands in both directions, in 2 dimensions. Your XY grid is a 2-dimensional surface, up, down, left, right, so it's going this way, vertical or horizontal. By putting that line in, it splits it into what's called a half plane. There's 2 halves to it. One side will be true, one side will be false when you pick an ordered pair. What you're doing is you're trying to find the direction to shade. So in this case, what's the easiest point that the line doesn't go through? 0, 0. So if I substitute in for 0, 0, I'm either going to get a true or a false statement. Is 0 smaller than 3? So it's true, right? If I substitute in for 0 for both of these, 0 is smaller than 3. Cover the truth. You want to hide the truth. You shade this way. Remember, you're always covering the truth. Now when I go to graph the other one, I put it on the same line, or same grid, I should say. What's my y-intercept with the second one?
-1.
And what's my slope?
1 over 1.
So I start at -1, go up 1 over 1, up 1 over 1. And is it a solid or a dotted line again? It's dotted again. Once again, I have to find that test point. Find out if either true, what side's true, what side's false. Does it go through the origin? So let's use it. Is 0 bigger than -1? Yeah. So it's going this way. So you wind up with this shaded region over here. The overlapped shaded region. Does that make sense?
What is the
I'm
overlap?
completely missing the whole covering what's true part. Like,
Okay.
how do you know which side?
If you go back to just real basic, y is greater than 3. in a number line, you would place 3 here, 0's here, 10's here. Do you agree?
Yeah.
Is 10 bigger than 3?
Yes.
Yes, so I'm covering the truth. Is 0 bigger than 3? No, it's false. This side is false, this side is true.
Okay, but like, how do you know which side is which? That's.
You pick a point. You pick any point you want. In this case here, if I wanted to pick 10, 0. Okay? It's not on either one of those lines, do you agree?
Yeah.
So if I take 10, 0 into here, is, is 0 smaller than negative 3 times 10 plus 3? Is 0 smaller than negative 27? No. This would be false.
Oh.
I cover the other side.
Okay.
All right? Same idea here. Is 0 bigger than 9? No. It's false again, so I'm shading on the other side. What happens is when you plot, this just being your XY grid, the line coming in splits it into either true, false on this side, or true, false on this side. One side's going to be true, one side's going to be false. Picking a point that works, that's easy,
Oh, okay.
tells you what it is.
All right.
That's all that is. Does that more sense?
Yeah, I
It's tough, especially if you haven't done it in a long time. You don't remember how that works. Yes, ma'am.
It's probably a stupid question, but will the lines always intersect each other?
They could be parallel. It's possible. It's possible. It could be parallel. It's not a big deal. You can be shaded on other ways. You can make real pretty funky stuff if you want. Yes, sir.
What do we do with the double shaded? Does that matter
Nothing.
at all? Or?
No, you're just showing me where the shaded region is. Where's the overlap? And I saw a lot of you guys doing this when you're graphing. Did you see how I did it? I just drew it. I mean, I had more lines going this way, but it was easier to see how that became like a basket weave, little crisscross pattern. It's the less messy you do your shading as you build into these, the easier it will be to figure it out. And that's going to come into play a lot more when we start building into, what would I can like this? When you get into something like that, where you're bounding out by a whole bunch of different possibilities, it becomes a lot cleaner to draw arrows. And we'll get to this, okay? It's really quite simple. All
Are
right?
you gonna require us to shade on like the homework and stuff?
That's how you do these. Right? Oh, well, let's try another one. Yes, ma'am, sorry.
So the dotted lines are just for like the solid ones are.
Yep.
I'm
Yep. Question was solid lines for greater than or equal to, greater than or equal to, or less than or equal to. Dotted lines if they're just less than or greater than. So we go into this one, we have 3 of them now. Okay, we went with 3 of them. We have x is greater than or equal to 0, y is greater than or equal to 0, and negative x plus 2y is less than 8. So draw your grid. X is greater than or equal to 0 is vertical on the y-axis. You agree? Is it a solid or dotted line there?
Solid.
Solid. What direction does it have to go? What way is true?
We have to pick a point that's not 0, 0.
It's going that way, isn't it?
Yeah, right.
Is it 5 bigger than 0?
Yeah.
So do this. Notice I'm just pointing 2 arrows going that direction. It becomes a little bit less messy. Same thing with y is greater than or equal to 0. It's moving up. So now just by looking at those first 2 parts, see how it's starting to be bounded within that first quadrant? See that? Your overlap right now is in the first quadrant between x is greater than 0 and y is greater than or equal to 0. Put in your third graph. Your third graph is set up in standard form. What's your y-intercept? Yeah, 0, 4. What's your x-intercept? Solid or dotted? Did that one go through the origin? Use the origin as your test point. Is 0 plus 0 smaller than 8? Yeah. So it's moving inward. Now, do I need to worry about shading anything over on this side? I don't, because I'm already bounded up here from the first two parts. So I just can do this. So my region winds up being, let me draw this up a little bit. Like that. It's moving up in here. And it's moving out from here. And moving down from there. You get an open-ended positive region. It's not fully bounded to the right. There would be no maximum value here. Okay? Not so scary? All right.
How do you see that we're doing this like this? How do you show that?
Yeah, that's fine. That's fine. And you'll start to see it because eventually we'll have something that'll bound itself into and turn it and create like a quadrilateral and all that stuff.
It's just dumb because this is bounded just in the first quadrant, right?
Yeah, and a lot of these do wind up being first quadrant problems, especially when you start building into the word problems, because you're never going to have negative values of pastries.
Who makes pastries linear? Like, that doesn't make any sense.
Well, I'll show
I'm
you.
just questioning the fact that the first word that came to mind that fit that situation is the word pastries.
Yeah, I know, it's kind of silly, but we're wasting time here. So here we go.
Is that me?
Yeah,
Oh, okay. Got to sign that?
sure.
We don't have to.
Look at those
Colton
red
can
pants.
sign it.
Yeah, I'll sign it.
Are you spelling your name right?
I don't know.
Janice! I didn't say anything.
Wow. Changes it. 12. Here. You know where the printer is out there?
Somewhere out there.
Dude, I made the paper, I didn't know why.
Dude, you made the paper.
I did. It's right around the corner.
Okay, I'll go walk around the corner.
You'll
Okay.
find it eventually. I'll just.
Just meander till you find
The
it.
giant.
Meander, yes, it's a word.
No one knows.
All right, look at this one.
Yay, number 11.
Mr. Murphy, do you know what FTLA stands for?
Flexible Learning Teaching Area.
Oh.
Are you being serious?
Wait, flexible teaching?
For the language.
Flexible Teaching and Learning Area.
Yeah.
If it's FL, is it FTLA or FL? It's FTLA, but yet they named the printer FLTA because.
Because she found me.
It's something. It's something. Okay. So we're going to bound this region. All of them are going to be solid lines, correct? So you have x is greater than or equal to negative 2, x is less than or equal to 5, y is greater than or equal to negative 1, or y is less than or equal to 3. Pretty straightforward.
What determines if they're solid line or not? Is it whether or not you
You can probably take down one. You can take down Holden's and put yours up now.
Alright.
Can I keep holding?
If you want to keep Holden's, that's fine. So you start with your grid. X is greater than or equal to negative 2. Well, is that horizontal or vertical?
vertical?
And which direction does that have to point? It's got to be going to the right, because the numbers are greater than this way. Okay. Less than 5, coming back the other way. So just within those two values, you've got a vertical boundary, or excuse me, two vertical stops.
Ask me
because you're open on top and bottom. Now your y equals are going to bound you off. Greater than or equal to -1, well, that's right there. Moving upward. And then less than 3. And you're right, this one created a rectangle. And it has 4 points of intersection. Yeah, because you're going in through this way. Could you tell me the ordered pairs of the vertices? Okay. Bottom right, what do you have? Five, -1. What's this one?
5, 3.
5, 3. -2. And then -2, -1. And you're saying, do we have to label the ordered pairs? You're going to need them as we start figuring out maximums and minimums. Because you're going to be given what's called a constraint function, where you're going to use those vertices that you create a boundary from to test a specific constraint. What I mean by constraint is there's what's called an objective function. Today they're going to be given to you. Tomorrow your objective function will be developed where you're going to figure out how do you write them via, is it a profit, is it a sales number you're trying to reach, is it, I don't know, there's a whole bunch. It's fun. Okay. I'll show you another one. You know what, let's just go right to the objective. Let's go right to the objective one. Then we'll do this.
I thought that said computer programming. I was like, I dropped that class for a reason.
And I'm going to find the maximum, minimum of our objective function. Our objective function, our constraint, is always given to us as the equation C equals something. In the homework tonight, it's going to be given to you. The constraint function changes. It's C equals something. 3x plus 2y, -x plus 7y, whatever. All right, it's just going to be given to you. You're going to find the maximum and the minimum value of that function given the following constraints above it. All right? Trust me, Lily, you're going to be surprised. This is actually really quite simple.
You always say that, and you're always wrong.
I'm not wrong. I'm not lying to you.
He's always like, it's so simple. You're going to see how simple it is. And then I cry.
I do?
And trust. You like the word trust.
It's true. Well, yeah, trust yourself.
Pretty straightforward.
Yeah.
Well, lines are pretty straightforward.
I get it.
Did anyone notice that none of those paths were genuine?
I know. I'll get over it. So what happens here is we start the same process. We go ahead and figure out our first two constraints, greater than or equal to 0 for x, greater than or equal to 0 for y. Does everybody agree by those first two values tells you that it's a first quadrant problem?
Yeah.
So all I'm going to do is throw arrows in my first quadrants, like this. So I know that takes care of my first two constraints. X is greater than or equal to 0, y is greater than or equal to 0. The second set of equations gives me in standard form. I can figure out my x and y intercepts. Cover and solve. What's your x-intercept? -15 for x, and your y is 5. So -15 is about here. Notice I'm writing it as an ordered pair right off the bat. And our y value is at 5. When I connect those two, will it be solid or not?
Solid.
Solid. I need a test point. What am I going to use? 0, 0. The reason why I'm using 0, 0 is because it doesn't lie on that line. So what's 0 plus 0?
0.
Is that smaller than 15?
Yes.
Okay. Now I'm bounding it this way. So 0, 0 is going to work here. Everybody okay with that? Put in the next one. What's your x-intercept of the last equation? 6. And what's your y-intercept? 12. Good. Is it okay that I'm not marking them off? Absolutely. Don't do it. Just place it. You know what I mean? Place it. Because when you get into a problem like this, when you cover out and solve, you have an x-intercept of 84, a y-intercept of 70. Just place it on the graph. You're just going to place it on the graph. Connect the dots. And G, what point am I going to use to test?
0.
What's 0 plus 0? It is 0. Is 0 smaller than 12?
Yes, it is.
It is. So now we've created this bounded region inside here that gives us that little quadrilateral, if you will. We know 3 of the 4 vertices of that. 6, 0, 0, 0, 0, 5, but we need to figure out this one. That's the point at which the 2 lines intersected. When you have 2 lines that intersect, you have a system of equations. So you wind up finding the intersection of 2 equations, negative x plus 3y is 15. Little trick here. When you go to find the intersection of the 2 lines, it's perfectly fine. Just turn it into equal. Because that's what you're doing. You're figuring out where the points run into each other. So they have to be equal. So you have negative x plus 3y equals 15, and 2x plus y is 12. When you solve a system of equations, there's multiple ways to do it. You've got substitution and linear combination. Do you remember what to use when?
Nope.
Okay.
It's both, so we can use an equal sign if it's less than or equal to, right?
Excuse me, sorry, Zach. In this case, we're trying to figure out where they run into each other, but yes, that is the main reason why. When you're dealing with these things, linear combination is usually when you have to multiply factors together so you can add the equations together to eliminate one of the variables. In this case, since you look at the first equation, you have negative x. If I add x to the other side and subtract 15, do I get x by itself? Use that because then you can use substitution. You add x and subtract 15. Oops. You wind up with 3y minus 15 is x. So just take that and substitute here. You're going to use direct substitution. You'll solve for y first. It's very easy to use substitution when you have one of the variables already with coefficient of 1. Okay? This is a whole bunch of review of Algebra 1 here, guys. So you have 2 times 3y minus 15 plus y is 12. Distribute combined like terms, you should get 7y minus 30. Y plus y.
Y equals 3. Y equals 7.
Oh, okay, there's an
Try
extra
again.
y there. I didn't get there yet.
Y is 6. You've got to add the y to it. When you take 2 times the quantity 3y plus minus 15, you get to add in the y after 3. Yep. There's no y in here. Look. Because you're taking into the x value, so that's plus y. Okay. So your y value is what? 6. So you know the y coordinate of that point is 6. To figure out the x, what do you do with the y? Put the y back in. So what's 3 times 6? What's 18 minus 15? So there's your ordered pair. Your ordered pair there is at 3, 6.
Hold on, where'd you plug this back in?
Where's the negative at?
If you plug it into the answer, the first one.
I substitute in, because we have 3y minus 15 is x. If 3 times 6 is 18, 18 minus 15 is 3. We don't have to worry about the negative because you're just manipulating back here. If you want to go back to the negative and you wind up with 18, subtract it over, you get negative x is negative 3, get rid of the negatives, so you get 3. Okay. I'm using it to make it easier with the one I moved around. So now you have 4 ordered pairs that you wind up to test for your constraint. The only one you had to do any work to find was that last one, so you list them. 0, 0, 6, 0, 5, oh, sorry, was it 3, 6? And 0, 5. With those 4 ordered pairs, you're going to test them at your constraint function. Basically, it just means you're going to substitute in the values of x and y into that constraint to find the maximum value. What was it, 3x plus 2y? Yeah. So you take that, you have 3 times 0 plus 2 times 0. 3 times 6, 2 times 0. 3 times 3, 2 times 6, and 3 times 0, 2 times 5. All I'm doing is substitution 4 times into that constraint. So what's 0 plus 0? 0. So it's 18. What is that? 27, oh, sorry, 9 and 12 is 21. And 10.
Sorry, where did you get the 3x plus 2y?
It was given. It'll be given to you. So it needs to be given to you. That C value right at the beginning of the problem.
Oh, okay.
That's what it was. That's your constraint, your objective function, if you will. Where's your maximum? So all you do is this. And where's your minimum? Here you go. You're done. So it wasn't that bad.
I didn't break it.
I know, but you don't like a lot of things. That's okay.
Yeah, you're right.
Yeah. But I need to get to another one, okay? Let's do another one. And it's okay to waste, you're gonna have to waste paper on these guys. You're gonna need space for a lot of this. Trust me. Trust me on this, okay?
Yeah.
Look at this. Same idea. Same basic idea. You have x is greater than 2. X is less, or excuse me, greater than or equal to 2. X is less than or equal to 5. Y is greater than or equal to 0. And y is less than or equal to 2x plus 12. Negative, excuse me, thank you. Negative 2x plus 12. And it wants you to find the maximum value of that constraint function given to you of negative x plus 3y. So basically that means whatever ordered pairs we figure out for some shaded feasible region, we're going to substitute into that constraint, figure out what's the biggest number and what's the smallest number. Or in this case, just the biggest number. Okay? So we plot it. Start with your grid. Colin, you'll figure this out real quick. Hopefully it won't be that bad. X is greater than 2 is a vertical line that goes through. Oh, it goes through 2.
You said not to be.
Which way is it going?
I thought you said not to be. Right?
Well, I just did this one. I just felt like it. Going that way. And then the other one is less than or equal to 5.
Now.
That's what we left. Y is greater than or equal to 0 means it's going up. So basically right now you have an open cup. Putting in the line now, we'll put a top on it. Now there's a couple ways of doing this. It's written in slope-intercept form, which means you have to mark off your stuff and walk your finger going out. Can I put it in standard form real fast? Bring two of them. Isn't that the same thing? 2x plus y is 12. Can I get my x and y intercepts really quick now? What's your x-intercept? 6. What's your y-intercept? You see how we did that?
Do we ever have to worry about keeping the sign or something?
When you worry about flipping the sign, when you cover and solve, you're automatically going to get the negative. It's going to move to the other side, it's up or down, depending on what it is. That's what's nice about it. You don't have to worry about. I know you're talking because you're not solving for anything. You're not multiplying by negatives or anything like that. You're just cover and solve. All right, it works. In this case here, your ordered pairs. Let's see, is 0 smaller than 12? So we've got a region that has these 4 ordered pairs in there. You know 2 of them right away. I'm going to move this around to move more space. I have 2, 0, 5, 0. I just got to figure out these 2 points. But I know what my x values are, don't I? What's my x coordinate here? 5, because it's vertical, isn't it? What's my x coordinate there? So if my x value is 5, what's 2 times 5? 10 plus what is 12? Where's your y coordinate?
-10.
What's negative 10 plus 12? 2. If I use either one of these, I'm going to get the same answer, aren't I?
You're gonna do the same answer no matter what. It's the same equation, just flip around.
It's the same equation, just move. What's 2 times 5? Oop. 10. 10 plus what is 12? 2. Negative 2 times 5 is what? What's negative 10 plus 12? 2. It works either way. Yeah. The other one, your x value is vertical, so you use 2 again. So negative 2 times 2 is negative 4. Negative 4 and 12 is 8. So your y value is 8. So your 4 ordered pairs that you're going to test at this function, 2, 0, 5, 0, 5, 2, and 2, 8. Substituting it is the easy part. I cannot stress the importance of using paper. Use space. If you make a lot of small graphs, it's very easy to get lost in your writing because the intersections where things run into each other. It's so much easier to space it out and use a bunch of use a bunch of space. Okay? Substituting values wise to go to maximum value, so it's just negative 2 plus 3 times 0, negative 5 plus 3 times 0, negative 5 plus 3 times 2, negative 2 plus 3 times 8. Boy, I bet you we can look at this and figure out which one is going to be the maximum value. 3 times 8. What's 3 times 8? Plus negative 2 is? So your maximum value is going to be at, here's your max. Where's your min?
First one.
Negative 5. Which one's smaller, negative 5 or negative 2?
Negative signs in here.
What I want you guys to do tonight, it's section 3.4 in your book, page 166, 12 through 20. It's all constraint stuff. They're giving you the constraint values. Cover and solve, quick graphs. Find your ordered pairs that intersect through, and substitute in. Okay? I did, Austin just reminded me last hour to flex that I didn't have it up earlier on the website, the tab for the book page. I put it up there now, so if you talk to anybody in the 3rd hour, let them know that it's up, or 6th hour, if you know what I mean. Okay? We'll develop the word problems tomorrow. It's very exciting.
Not for personal use.
Ask Izzy.
Oh, she's the girl who got the thing, okay.
Actually, you do that too. I would say Murphy uses sarcasm. It's very effective. Actually, no. I told you something on gathering. I looked at his. You don't have to